Hi friends, welcome to this video. So here I am continuing KCET 2018, right? So 1 to 5th question I had made the video and the link will be in the description box, and the continuity of that, the question number 6 is, for an ideal gas the compressibility factor is, right? So this compressibility factor will be given by Z, which is nothing but PV upon nRT, right? So for ideal gas, what is ideal gas? Ideal gas, one which obeys all gas laws, right, at all pressure and temperature. So there we learn this equation, PV is equal to nRT, right? So the gas which obeys this pressure, volume and temperature relation, that gas we call it as ideal gas, right? PV is equal to nRT. So they have asked, what is the question? They have asked, what is the compressibility factor of ideal gas? So compressibility factor is represented by Z, which is nothing but PV upon nRT. So for ideal gas, I can substitute PV is equal to what? PV is equal to nothing but nRT. Right. So just if I substitute nRT divided by nRT, so here this can cancel out and it is 1. So for ideal gas, the compressibility factor Z is nothing but 1. So answer is B, or the second option, which is 1. I hope you got it. So this is about 6th question. Talking about 7th question. So here they have given Kp and Kc, and they have given even they have given the relation Kp is equal to Kc into RT raised to delta n, right? So see how easy they have made this option. So they have given this relation. We know this relation. We have to tell what is the delta n. What would be the value of delta n for the reaction? This reaction they have given, we have to show it delta n. So you should remember how to calculate delta n. Delta n can be calculated like this. What is delta n? See, ammonium chloride, which is solid, is in equilibrium with ammonium gas and HCl gas, right? So delta n is nothing but the number of product minus number of reactant. So here number of product, these are product, right? So number of product minus number of, this is reactant. So product is gas here. So 1 ammonia plus 1 more HCl. So 1 plus 1 is the number of product minus number of reactant. But here number of reactant, you can see that it is solid phase. So if it is solid phase, it is, you won't consider that. So minus 0. So what it is, 0 minus 2 minus 0 is nothing but 2. So that is the value of delta n. So the value of delta n is what? 2. Option 4th one, or the D. But in competitive exams like national level competitive exams like NEET and JEE, they won't give this equation. They will give just this reaction, and they will ask you to calculate Kp. They might have given Kc or what, right? Then you have to substitute. First you find out delta n, then you will find it Kp is equal to Kc into RT raised to delta n is nothing but 2 now. Then you will substitute Kc RT raised to delta 2, and you will calculate this Kp. Like that the questions they will ask. But for KCET this much is enough, right? So this is about question number 7th. Talking about question number 8. So the question number 8 is, acidity of Bf3 can be explained on which of the following concepts, right? So acidity of Bf3, they have mentioned the acidity term only. It means this Bf3 is acidic in nature. That can be explained by which of these 4 concepts, right? They have given ABCD option, we have to choose. So to tell acidity or basicity, acidity, right, acidity or basicity, we explain by 3 concepts are there, right? How many concepts? 3 concepts. One is what? Arrhenius concept. Arrhenius, which tells that acid is a substance which gives H plus and base is a substance which gives OH minus. So this is the Arrhenius concept. Second comes Bronsted-Lowry concept. This B option is the right, same Bronsted-Lowry. I will shortcutly write B and L. Bronsted-Lowry concept of acidity and basicity. According to Bronsted-Lowry concept, acid is a one which gives H plus, base is a one which takes H plus, H plus. According to Arrhenius, what? Acid is the one which gives H plus, base is the one which gives OH minus. But according to Bronsted-Lowry concept, acid is the one which gives H plus, base is the one which takes H plus. To explain this, he will explain about this one, HCl plus water. HCl is acid. Why it is acid? It is going to give this H plus to this water. So what happens? He will write like this. So H plus it is giving, so it forms Cl minus and H2O becomes H3O plus. So it is acid. Why it is giving H plus to water, and this water is taking H plus, so it act as what? Base. So this is about which concept? Bronsted-Lowry concept. And the third one is Lewis concept. The third one is what? Lewis concept. According to this Lewis he tells that acid is a one which takes lone pair of electrons, and base is a one which gives lone pair of electron. For example, ammonia is there, NH3, right? Ammonia, it is having one lone pair like this, and here I have Bf3. So Bf3 structure is like this, right? So here Bf3 is there, right? So this, if you count the number of sigma bonds, 1 2 3, 3 sigma bonds are there. Each bond has got 2 electrons, so 2 4 6 electrons, 6 electrons are there. But we know that octet rule, it should contain 8 electrons. It means it is deficient of 2 electrons, so it will be having an empty p orbital like this, right? So empty p orbital, right? Because its hybridization is sp2, and there will be unhybridized p orbital. This is what? Unhybridized p orbital, right? Which is also called as empty, because no electrons, so we call it as empty p orbital, right? So what happens? Let me change the color of the pen. Yes, so here lone pair is there. That lone pair will be taken by this Bf3 molecule. So it forms what? Like this it will form. Bf3 was like this initially, right? Now the ammonia NH3 comes here with this lone pair, right? Like this, right? So this is nothing but the Lewis concept. So here ammonia is giving this lone pair of electron, so it acts as Lewis base. So it acts as what? Lewis base. Just a minute. So it acts as what? Lewis base. Whereas this lone pair is taken by this compound, so this act as what? Lewis acid. So according to concept of Lewis, what? Acid is the one which takes lone pair. See here, it is taking lone pair, whereas base is the one which gives lone pair. See here, ammonia is giving lone pair, right? So this one Bf3's acidity is explained by which concept? Lewis concept, not the Arrhenius concept nor the Bronsted-Lowry concept. It is explained by what? Lewis concept. So option is C. Talking about 9th question, for an redox reaction, they have given this reaction. We have to find, right? So the question is half here. We have to find these things, X, Y, Z. Z they haven't mentioned. The question is find X, Y, M and N. Right, 4 unknown we have to find. What are the unknowns? X, Y, M and N. So this is X, this is Y, M and N we have to find out. And they have given option A, B, C, D, X, Y, M and N. In 4 options they have mentioned it. Right, so we have to find it. Right, so it can be done only by balancing. Right, balancing, we know that. So let me write the reaction. Reaction is given here only. So this is the given reaction. Just we have to find X, Y, M and N, right? So before doing that, see, let me write it like this. See, I have MnO4 minus, and it is converting to what? Mn2 plus. So MnO4 minus is converting to Mn2 plus. See, MnO4 minus is converting to Mn2 plus, like this, right? So if you see number of oxidation state A, I will write it. How many molecules of electron has been transferred, that we have to mention. See, if you know oxidation state of manganese, how to calculate? X plus 4 into here 4 into oxygen oxidation state will be -2. Overall MnO4 minus is there, so -1. So X will be what? X minus 4 to the 8 is equal to -1. Minus 85 it goes here, plus 8 minus 1, it is +7. So I will rub it. So what is the oxidation state of manganese? So oxidation state of manganese in KMnO4 is +7. So it is +7. Whereas here it is Mn2 plus. So change how many change? From +7, it has come to +2. So change, if you see, it is see from 2, 3, 4, 5, 6, 7, right? So the change is 5 unit it has changed. So A1 value for this is 5. And next here I have this one. Oxalic acid is converting to carbon dioxide. Just let me write it here. So oxalic acid means what? H2 C2O4 is converting into what? Converting to carbon dioxide. If you see oxidation state of this carbon, it can be easily calculated. How? Let me keep it as X. Hydrogen will be +1, 2 into +1 plus 2 into oxidation state of carbon is X, plus 4 into oxygen will be always -2. Overall charge is 0, so it is 0. So here 2 plus 2x minus 8 is equal to 0. So 2x minus -6, it is go +6, x is equal to +3. So oxidation state of carbon here is +3, whereas in carbon dioxide it will be +4. You can calculate by yourself only, right? 2 oxygen, 2 2s are -4. If it goes there, it becomes +4. So if you see how many carbons are there here, you can see here 2 carbons are there. 2 carbons, but here only 1 carbon. So first I will balance this carbon. So 2 carbons. Right, I hope you are getting it. How many carbon now? I have 2 carbon here, right? So from +3 to +4, how many unit change? 1 unit change for 1 carbon. But how many carbons are there? 2 carbons. So per unit change will be how much? 1 +3 to +4 1, but 2 carbon, so it is 2, right? So just what I will do, let me change the color of the pen. So 2 I will multiply to this whole, and 5 I will multiply this to this whole, right? So what I will get? So I will get overall, I will get like this. See, 2MnO4 minus, here 5 I am multiplying to this, so it becomes plus 5H2C2O4. Left hand side I have written, now it is arrow here. Again 2 I have multiplied to manganese, so 2Mn2 plus 5 I have to multiply here. 5 2s are 10 CO2, right? So here before M it is what? X, and before H2C2 for oxalic acid it is Y, and Mn behind M it is M, and behind carbon dioxide it is N, right? So our X, Y, M, N value are 2, 5, 2, 10. 2, 5, 2, 10. So option is B1, 2, 5, 2, 10. So the person who knows to balance this reactions, that person can easily solve this problem, right? So this is belongs to redox reaction chapter, right? So this is about this question. So it is directly from NCERT only, right? These things we will be doing in board exams. Now lastly, talking about 10th question. So here from 6th to 10th I am making the video. So this is the last question for this on this video, right? So this H2O2, if you know the structure of H2O2, H bonded to oxygen, again one more oxygen and hydrogen, right? So if you see the oxidation state of, see this hydrogen will be +1 because it is more electronegative atom, it takes the electron density towards itself. So oxygen oxidation state is -1, and for this it is +1, no doubt. Similarly here hydrogen it will be +1, and for this oxygen it is -1, right? And both are oxygen, same electronegativity. So here no, it will not pull the electron density. Electron density will be at center only. So oxidation state of oxygen is -1. However, during a reaction, if O2 is liberated, oxidation state of O2 is 0. So from -1 there is increase to 0. So increase in oxidation state, or the oxidation number, we call it as what? Oxidation, right? And this is what? This is oxygen is oxidizing here, right? So it act as what? So this H2O2 act as here reducing agent. It act as what? Reducing agent, right? So in this process this H2O2 act as what? Reducing agent, right? But there are few more cases in which the same H2O2 releases H2O water, in which oxidation state of oxygen, if you calculate, it is -2. Why it is -2? Oxygen is bonded to 2 hydrogens like this, Electronegativity of hydrogen is +1, so here -1, here this is +1, again -1, -1 is -2. Oxidation state of oxygen I am calculating, whereas oxidation state of oxygen in peroxide is -1. H2O2 is nothing but hydrogen peroxide. So here -1 to -2, it has reduced. So it is what? Reduction has happened. Reduction happen. So here H2O2 act as what? Oxidizing agent. Here H2O2 act as what? Oxidizing agent. Here it act as oxidizing agent. When H2O2 gives H2O, it acts as oxidizing agent. It means the H2O2 will be reducing, right? Reduction happens. The same H2O2, if it gives O2, oxygen gas, that means this H2O2 will be oxidizing. So it acts as what? Reducing agent, right? So the same H2O2 can act as reducing agent and same H2O2 act as oxidizing agent. But when it acts and all that thing you have studied in hydrogen chapter, that too about hydrogen peroxide, you can go through that. If you don't know, if you ask me, I can tell about that also. But here the question was, H2O2 is oxidizing agent. Yes, it is oxidizing agent. B option, it is reducing. Yes, it is reducing agent. Both oxidizing agent and reducing agent. The appropriate answer is C1, because it acts as both oxidizing agent as well as reducing agent. So option D is wrong one. Neither oxidizing, no, it acts as, right? So option C is the correct answer for the question number 10, right? Thank you.